Waves play an extremely important role in a great many areas of our lives. Sound and light are waves, as are earthquakes. Radio broadcasting, radar, and laser are also based on waves. Waves can be categorized by various properties. The most common categories are based on the medium through which the waves travel. They can also be grouped by polarization and frequency. Depending on the medium, waves can be mechanical waves, electromagnetic waves, and gravitational waves. The functions that describe the quantum state of systems can also be considered waves. They are therefore also called wave functions. The simplest mechanical waves are sound waves that travel through various gases. The source of the sound causes the gas molecules to vibrate. Then, the molecules that are already vibrating cause neighboring molecules to vibrate as well. This process is repeated, and this is how vibration propagates. Mechanical waves traveling through gases are always longitudinal. That is, the direction of particle movement is parallel to that of wave propagation. This is because particles in the gas do not attract one another, and thus shear forces are not exerted on them. A single particle can only cause particles that are in front of it to vibrate. Longitudinal waves cannot be polarized. Mechanical waves traveling through solids or liquids can either be transverse or longitudinal. Transverse waves are waves in which the displacement of the particles is perpendicular to the direction of wave propagation. When we pluck a guitar string, the wave travels along the string, but the vibration is perpendicular to the movement of the wave. If vibration takes place throughout the same plane, we say that the wave is linearly polarized. Most of the waves observed in nature are not purely transverse or longitudinal, just as transverse waves are not always polarized in a single plane. These movements of particles in a certain medium usually occur at the same time. Any complex wave motion can be described as a combination of a longitudinal and one or more transverse waves. For example, when we look at waves on the water, the particles are moving not only up and down, but also backwards and forwards, so water waves can also be described as a combination of longitudinal and transverse waves. The reason for this is that water is not a compressible medium, so the downward moving particles do not compress the particles under them, but push them to the sides. Waves traveling through a solid medium, for example seismic waves, are even more complex. An elliptically polarized wave is a composition of two transverse waves, but this wave can be circularly polarized in special cases. A circularly polarized wave can be easily generated by tying one end of an elastic rope to a fan blade and keeping the rope stretched by pulling the other end. To transform a circularly polarized wave into a linearly polarized wave, one needs a polarizer. For mechanical waves, this polarizer is a gap. Once the wave passes through this gap, it becomes linearly polarized. If another polarizer, perpendicular to the first one, is placed in the path of the wave will not pass through it. Electromagnetic waves are not vibrations of a material medium. In fact, they do not need a medium to propagate, and they propagate the fastest through a vacuum. They are generated as the changing electric field produces a changing magnetic field, which in turn generates another changing electric field, and this process is repeated. When electromagnetic waves are generated, there are no vibrating particles, so it is not easy to interpret polarization in this case. However, if we identify the direction of the vibration with the changing electric field intensity vector, electromagnetic waves are also considered transverse waves, so their polarization can be linear or more complex. Natural light is a wave that is not polarized in a single plane, as it does not come from a single source. Numerous molecules or atoms generate it independently of one another, polarizing it in different planes. Natural light can be polarized with optical polarizing filters. Gravitational waves are generated as a result of accelerating masses. Essentially, they are considered ripples in space-time. They result in the expansion and contraction of space-time at a given point. This can only be detected with very precise instruments, and only very large accelerating masses, such as the components of a binary star system orbiting around each other, can create significant gravitational waves that can be detected.